We have an update on offset parent matrix option in Advanced Skeleton. There is a couple of new things to show you, and there is a couple of things to show you about the differences between a offset parent matrix rig and a standard rig in Advanced Skeleton. So, very quick recap on offset parent matrix. Basically, that's something that's been around since Maya 2020 and allows for matrix values to be directly connected into transform nodes, and you can thereby create dependency graph setups and rigs which do not rely on the regular constraints and therefore can run faster. In Advanced Skeleton, under preparation rig, here is the option where we turn on offset parent matrix as a help image here. So one of the updates is that the newer versions of Maya now allows you to export an FBX, and the rig can be using offset parent matrix nodes, or in other words, the internal baking of animation in Maya from the control rig onto the deformation system bones that are needed for game export now works with offset parent matrix in the latest versions of Maya. So this has been reflected upon in Advanced Skeleton, whereas the older version of Advanced Skeleton before this was possible, then as soon as you turn on offset parent matrix, the game engine option would be turned off because they were not compatible, but this is now possible to use offset parent matrix rigs to export to FBX as long as you're using the newer versions of Maya. Another major update to Advanced Skeleton is that the offset parent matrix option, when you turn it on, it was just reflected upon in the build of the body rig. But now in the new version of Advanced Skeleton, even for the face rig, if you use the offset parent matrix option here, all constraints are replaced with matrix nodes and giving you a faster rig. Okay, so to dig deeper into this, let's go ahead and open a demo character. We'll grab Tuna. Now the demo characters by default are using the traditional constraints and not offset parent matrix. So to convert this into an offset parent matrix rig, all we gotta do is go into the preparation rig option here and turn on offset parent matrix, go to body, build, and hit rebuild Advanced Skeleton. And what we can also do now, we can go into face and hit rebuild face to get a offset parent matrix version of the face rig as well. And there we go, we got a full offset parent matrix version of the rig. If we want to double check that that's how it's set up, we can go in and have a closer look under deformation system. If we look at any of these joints that are controlling the body, you see there's nothing coming in on the transforms because it's all connected through the offset parent matrix nodes. And even if we go to all the face setup joints, you can see it's the same here. Nothing in transforms, all in offset parent matrix. Okay, now to compare the offset parent matrix version of this rig with the old standard version, all we're going to do is just save out this file, and then I'm going to reference in the two versions of this rig, so I have the two side by side in the same scene. So I'm just going to save this out. I'm calling this Tuna _OPM for offset parent matrix. Then I'm going to go and create a new scene, and to reference it in, I'm just going to use the selector file create reference. And there we have our newly created offset parent matrix version of Tuna. We'll move him off to the right. And then we'll go ahead and reference in one of the original versions. And we'll move him a little bit off to the left. All right, so we got the two versions here. To make sure we don't get confused which one's which, let's just put a label on it. OPM for offset parent matrix, and that's this guy here on the right. Okay, so at first glance, they look identical, but one thing we can do quickly to check is to see one of the main differences is on the bones. So if you select any of the deforming joints on either one of these, so here on the original version, you can see that all the transformation channels are connected up with constraints and in some cases direct connections. But on the offset parent matrix, all the transforms are freely available and 0 values, but the connections are coming in through the offset parent matrix connection. Now, functionality-wise, on the rig, there's actually a couple of small differences as well. The reason for that is because offset parent matrix nodes easily allow for other kinds of space type setups. Let's have a look at the IK arm. If we select the IK arm or the offset parent matrix version, we can see that we have some options for following here. By default, it says to follow main, but you can also change it to follow root or follow chest. Whereas the original version here does only have a follow option. So the original rig follow here refers to parent. So the parent of the arm is the scapula. So we can test that. So if we rotate the scapula, you see the IK handle is not following. If we were to turn follow on, then any of the parents, such as scapula or any higher parent in the hierarchy, the IK will follow. So on the original type of rig, follow always is the one follow attribute that is set whether or not to follow that parent. But in the offset parent matrix version of the rig, IK handles, they have various numbers of spaces, and the number of spaces is going to be dynamic and depending on how many IKs it will find above in the hierarchy. So default follow main, which is obvious. If we move the main, the IK here follows, but it can be turned off. So you can turn off follow main. And you see here that even when you move the main, the IK will remain, well, in this case, back at the very origin where it comes from. But turning on follow main, now it's going to follow the main, but it does not follow other things, such as the root. If we turn on the next layer, follow root, the IK controller is now following the root, but it's not following the chest. And again, the next level of following here is it can follow chest. It will now follow all the spaces all the way. So it follows main, it follows root, and it now also follows chest. Now this ability to follow also goes for the IK leg. So the IK leg on the offset parent matrix version of the rig has the ability to follow the root. So by default it will not, but it can be turned on. Now as a consequence of the IK here being able to follow the root, it means the vice versa is not possible. See, in the original version of the rig, there is some attribute on the rig called center between feet, which means you can turn it on. Then you can start moving the IK legs, and you'll see the root will partially follow the 2 feet to stay centered between the left and right IK feet. So in this case, that's a function where the root follows the IK feet. Now, obviously, you can't have the root following the feet and the feet following the root. So here we see we can have the feet following the root. And that's why on the offset parent matrix version of the rigs, there is no attribute on the root for center between feet. And lastly, just to demonstrate that an offset parent matrix version of a rig works with animation FBX export now, we will do a demonstration of that. So let's just go ahead and go to our reference editor for a start. I'm going to remove the other guy and we'll be left with just our offset parent matrix version here. Actually, one more thing we can do to demonstrate here is the performance that we're getting. So we can apply some animation to this guy just to see that it performs quite well when it's using offset parametrics nodes. And a quick way to test that is we can go to the motion capture library and apply some animation. So we'll apply both body animation and face animation to see how it performs. So let's just go ahead and grab the range of motion face animation first. And let's see how that plays. Let's go and get some cool motion. How about Michael Jackson motion? So we got body animation and face animation. And to see how this plays back, let's go to display heads up and show the frame rate. And we'll say we want to play back at free speed, so it'll play as fast as it can, and we can see how fast that's going to be. And let's hit play. And that's pretty good there. We get around 65 to 70 frames per second playback with animation on the majority of the controllers. And then let's do the demonstration of that. This rig, which we can see all the deformation joints do have no direct channel connections, but offset parametric connections, and that works now in the newer versions of Maya with exporting to FBX. So let's do that. Let's go ahead and grab this clip and export FBX. I'll call that Michael Jackson Dance. And to test that clip, we'll just go new scene and input, and we can see we have all the animation on the face and the body. And if we take a closer look in the outliner on the skeleton itself, you see that the animation has indeed been converted from the offset parent matrix channels back to normal transformed channels, so it can work in a game engine. Alright, that's it for this time. I hope you have enjoyed this video, and I'll see you next time.